After studying types of supports, next we have is types of beams. So there are different types of beams. Now this beams, they are actually categorized based on the type of supports and positions of supports which are supporting the beam. So the first one is a simply supported beam, a continuous beam, a cantilever beam, a propped cantilever beam, and a overhanging beam. So all these are different categories of beams, okay, and these are actually categorized, as I told you, based on the type of support and the position of support where actually they are placed for the beam. So the first one, simply supported beam, which you already seen in the previous supports. So this simply supported beam, so as you can see, it is a beam which consists of simple supports. So such a beam can resist forces normal to the axis of the beam. So that is nothing but it is a beam which can resist the translation of the beam along only one direction. So simply supported beam, it is a beam which is supported at both the ends, so that type of beam is called as a simply supported beam. And the supports may be either roller or it may be hinged. So the end support conditions here, they have shown roller, but they can either be roller or they can be also a hinged type of support. But the thing is, always the supports will be at the end of the beam. So that is what is called as a simply supported beam. Okay, the next one is continuous beam. Now what is continuous beam? Continuous beam is a beam which runs continuously, or it has more than 3 supports, minimum 3 or more than 3 supports when it has. So such type of beam is called as a continuous beam. So as you can see, you have a beam which is supported at 3 points A, B and C, wherein if you see to the supports at A and at C, you have a hinged support, whereas at point B you have a roller support. So any beam which basically has 3 or more supports, they are called as continuous beam because it runs continuously. So this is about the continuous beam. The next is a cantilever beam, a very interesting type of beam. A cantilever beam, it is a beam which is fixed at one end and which is free at the other end, Okay, now this cantilever beam, as you can see, it is fixed at one end and at the other end it is free. The best example what I can give you for this cantilever beam is the shajja for the window. So everybody just imagine you have windows at a home, and on the outer side of the window there is a small projection on the top. Which will avoid water from entering inside. Okay, so that is what is called as a cantilever, wherein one end is fixed to the wall and the other end is free. In the similar way, a beam which is fixed at one end and free at the other is called as a cantilever beam. The next is propped cantilever beam. So propped cantilever beam is nothing but it is again one side of the beam is fixed and the other side is simply supported. So nothing much difference between a cantilever beam and a propped cantilever beam. So propped cantilever beam has an additional support at the other end of the beam. So a beam which is basically fixed at one end and a propped or which is simply supported at the other end is nothing but it is a propped cantilever beam. Okay, now the next part, overhanging beam. So overhanging beam means we all know actually what is a simple meaning of overhanging. What is overhanging? It is nothing but apart from some span, it is hanging without any support. It is hanging without any support. The same thing as you can see in the diagram. So there is a beam which has two supports at A and B, and after B some part of the beam is overhanging, so it is not having any support. It is not having any support in this portion of the beam, and you have a load which is acting in the vertical direction at point C. So since some part of the beam does not have any support and it is hanging, that is why we name it as a overhanging beam. Okay, so it basically it is a beam which extends beyond the supports, so in the figure it is seen that the beam extends beyond the support B up to C. So this part BC is nothing but it is a overhanging beam. It is the overhanging beam. Is that clear? So these are the types of beams. These are the types of beams. Quickly we shall recap. Simply supported beam. What is simply supported beam? It is nothing but it is a beam which is supported at both the ends, and the supports may either be a roller type of support or it might be a hinged side type of support. The next one is a continuous beam. So continuous beam is a one which has three or more than three number of supports. So that is what is called as continuous beam. The next one is a cantilever beam. So as soon as we come across cantilever beam, the example which would strike your mind is the chaja which is provided on the top of the window. So basically a cantilever beam is nothing but it is a beam which is fixed at one end and free at the other end. The next one is immediately propped cantilever beam, wherein it is a beam which is fixed at one end, but it is simply supported at the other end. Okay, so propped cantilever. The next and the last one is overhanging beam. Wherein you have some portion of the beam which is hanging in air. It is not being supported. So if you just look at this diagram, you have a beam which has supports at A and B, whereas this part of the beam, that is BC is hanging. It is not being supported. So this portion BC is the overhanging portion, and hence it is termed as overhanging beam. I hope types of beams are also clear to you. Okay, so the next part we shall discuss about the types of loads. Now, what are the different types of loads which are actually going to act on these beams? So in the first part we studied what are the different types of supports. In the second part we studied what are the different types of beams based on the support conditions. Now the last part what we are going to study is what are the different types of loads which are actually going to act on the beams. The first one is concentrated load. The second one is uniformly distributed load, and the third one is uniformly varying load. Okay, only three types of loads. Concentrated load, uniformly distributed load, that is UDL, and uniformly varying load, UVL. Let us see what are these different types of loads. Concentrated load. What is concentrated load? As the name itself suggests, a concentrated load is a load which is acting at a single point. So it is concentrating on a single point, and that type of load is actually called as a point load. Or it is also called as concentrated load. So you can see in this diagram you have three loads, that is 6 kilonewton, 2 kilonewton and 5 kilonewton load, which is acting at a single point in the beam AB. So these loads 6 kilonewton, 2 kilonewton and 5 kilonewton, which are acting at a single point on the beam. They are known as concentrated loads or point loads. The reason being they are acting at a single point. Okay. One more thing what you need to keep in mind is concentrated load need not always be a vertical load. So here I've just shown an example of vertical loads. So concentrated load. Okay. So concentrated load can be either a horizontal load or a vertical load or a inclined load as well. But you should keep one thing in mind, that concentrated load is a load which is acting at a single point, So here I have just taken a vertical load, but they may be horizontal load or they may also be a inclined load which comes under concentrated load. The next one is uniformly distributed load. A very interesting type of load. As the name itself says, it is uniformly distributed. If you just look at this diagram, so in the span of A to B, that is 3 meter, you can see that the load is being uniformly distributed along this 3 meter, and what is the intensity of load? Intensity of load is 20 kilonewton per meter. I want everybody to keep the units in mind. Now see, this concentrated load, since this load was acting at a single point, the unit of concentrated load is always kilonewton, newton and so on. Whereas for uniformly distributed load, since it is distributed along some of the span, the unit for this UDL is kilonewton per meter. So the intensity here is given per meter length, means per unit length it is given, Okay, so in the diagram, if you can see, that the beam of span 3 meters is subjected to a uniformly distributed load, that is 20 kilonewton per meter. Now we all know that we have three equations of equilibrium. Which are those? It is sigma fx, sigma fy and sigma moment. Now yes, so we were discussing about UDL. So this UDL, as I told, 20 kilonewton per meter acting over a span of 3 meters. So we have three equations of equilibrium, that is sigma fx, sigma fy and sigma moment. And we all know that any problem given to us, any type of loading in that problem first needs to be converted to either horizontal or vertical load, so that we can use the same in equations of equilibrium. Now this UDL, which is in the form of a rectangle, so you can see the nature of this loading. It is in the form of a rectangle. So 20 kilonewton per meter is acting over a span of 3 meters. Now we need to convert this load into a point load. So in the next part, we are going to study how actually we convert this UDL to a point load. So to convert 20 kilonewton per meter UDL into a point load, which is acting at the center of the particular span. In the sense, so we have a 20 kilonewton per meter load over a span of 3 meters. So per meter it is 20 kilonewton. For 3 meters, how much it will be? It will be obviously 20 into 3. 20 into 3, that is 60 kilonewton. So you will have a 60 kilonewton load which will be acting. So this 60 kilonewton load, where will it act? Where will it act? It will exactly act at the centroid of this rectangle. Centroid of this rectangle. Where is the centroid of this rectangle? Centroid is nothing but it is exactly at the mid. It is exactly at the mid. So this 20 kilonewton per meter, it can be converted to a concentrated load which will act exactly at the center, that is 1.5 meters from A as well as 1.5 meters from B. So that is what is being told here. To convert the 20 kilonewton per meter UDL into a point load which is acting at the center of particular span, so magnitude will be 20 into 3 because it is 20 kilonewton per meter over a span of 3 meters. Okay. So the next type of load which we are going to discuss is uniformly varying load. Uniformly varying load. So that was uniformly distributed load. This is uniformly varying load. Uniformly distributed means it is distributed uniformly. Here it is varying uniformly. So the notation of this uniformly varying load is in the form of triangle. In the form of triangle. So that was in the form of rectangle. That was in the form of rectangle. So this was in the form of rectangle with 20 kilonewton per meter acting over a span of 3 meters. Whereas UVL is in the form of a triangle. Unit of this is 2 kilonewton per meter acting over a span of 2 meters. Now again, this is a triangular type of loading. Again, we need to convert this triangular type of loading to a point load. To a point load in the same way as we did it for the UDL. As we did it for UDL. Now how do you convert this to a point load? Now just recall back, for UDL it was 20 into 3. 20 into 3, that is area of a rectangle. Area of rectangle, that is length into breadth. Length was 3 meters, breadth was 20 kilonewton per meter, and that is why we had taken 20 into 3, that is 60 kilonewton. Here since it is a triangle, so the conversion of this UVL to a point load would be area of triangle. Area of triangle. So we all know what is area of triangle. Area of triangle is half into base into height. Half into base into height, where base is 2 meters, that is the length of the beam. Height is 2 kilonewton per meter, that is the intensity. That is the intensity. So it is half into base into height. So when you calculate this, it will be 2 kilonewton. So 2 kilonewton is the point load. 2 kilonewton is the point load. Now where is it going to act? It is going to act at the centroid of the triangle. Centroid of the triangle. Now UDL, after converting, it would act at the centroid of the rectangle. That is exactly at the mid. Exactly at the mid. Whereas similarly in this UVL also, after converting it to a point load, it is going to act at the centroid of the triangle. Now, where does centroid of triangle lie? Where does centroid of triangle lie? Very important. Now see, in this part of triangle, the pointed edge is called as apex. It is called as apex, whereas the other end is called as base. Okay. So we were discussing about this location of this point load, that is after converting. So conversion is very simple. It is nothing but it is area of triangle, that is half into base into height. Half into base into height. After converting, you get it as 2 kilonewton. Now this 2 kilonewton actually acts at the centroid of the triangle. So as I told you, the Pointed edge of the triangle is called as apex, whereas the other end is called as base. The centroid of triangle always lies at the length of two-third of base from apex or one-third from base. So that is what is being shown here. So this 2 kilonewton is two-third of 2 meter. Two-third of 2 meter. Two-third of 2 meter from apex, or it is two-third of 2 from apex, or one-third of this 2 meter from the base. One-third of 2 meter from the base. Okay, so the location of this 2 kilonewton is very simple. It is centroid of triangle, which is measured two-third from the apex or one-third from the base. One-third from the base. Okay,